right, so today again was my running day. So that went okay. We did more like some sprint drills, so that was pretty fun. We just did like cones, um, kind of in like a semicircle, and then different kind of drills with that. We did some like 5, 10, 5s, that type of stuff. Um, did like I'm trying to remember the exact yards. I believe it was 90, yeah, 90, 45, 45. So you're doing 90 yard sprint, 45-second jog, and then 45-second walk. That was kind of our warm up. So we did, I believe we did 3 of those. Um, and then we did the cones. So we had them like in that little semicircle. We would like run to each one. Then we'd like side shuffle, back pedal, all the different movements. We did that one for 5 rounds, and then did like a square. So you'd sprint up, side shuffle, back, side shuffle over. And we did that one for 5 rounds as well, and then just like a little like cool down, so we walked. But today, this one's kind of appropriate for what I did today, but talking about ventilatory response to exercise. So biggest thing obviously is going to be, as you increase your work rate, you're going to have to increase your ventilation, or how like much you have to breathe to take in oxygen, because your body's just going to need it. It's going to need the extra oxygen and take up some of those electrons on that third pump of ETC. There is a certain point where we can't basically deal with, we have to hyperventilate basically. It's called our ventilatory threshold. So basically when you look on a graph, it's going to be linear into a certain point that's going to go exponential. So once we've reached that point, anything above it's going to be hyperventilation. So, you know, you're the whole time. One way you can test to see how well someone is doing during exercise is talk test, which is basically you have them do exercise and then you have them talk to you. So VT1, they're going to be able to get almost sentences out, so about 3 to 5 words between breaths. VT2 is going to be the more extreme, where it's literally 1 word before they're able, or before they're have to breathe. So it'd be like, you know, I'm doing this, that. Your body's really focusing on breathing. There's a really cool thing you can do with this, because we have these controllers, our ventilator controllers, on our carotid arteries. They're just carotid bodies. Their whole idea is to sense CO2 coming through them, showing that, you know, increased CO2 forces us to breathe. So you can do this cool little thing where a lot of like free divers do it. If you hyperventilate, you're getting a lot of that. You're focusing more on getting CO2 out than bringing O2 in. So you get rid of a lot of that CO2 out. So you're actually able to hold your breath a little longer, because your CO2 levels in your blood are lower. So your carotid arteries aren't like, oh, we need to, or not carotid arteries, your carotid bodies aren't like, oh, we need to breathe right away. So it's kind of delays that response a little bit.